You don't know it. It doesn't matter. Okay. Hypothesis test. Now we're doing means instead of proportions, so it's called a one sample t-test. But what do you think it's called in the calculator? T-test. So in the calculator, look for t-test. Is everybody okay with using the calculator as opposed to doing by hand? Please. We have the normal model, find the standard deviation. Okay, good. So I know in the calculator it just says t-test, not one sample t-test, just t-test. Okay, so I'm going to go through what I gave you on your piece of paper, just to show you like what each thing should look like. So the phantoms. So P is the population parameters. So it's like, what are we trying to test? Well, when you're doing a t-test, it's about the mean of something. So it's going to be, your variable is going to be mu equals the mean of something. Situation. So I kind of gave this away, but this is the symbol for what? Mean, what kind of mean? Population. What's the symbol for a sample mean? X bar. X bar. That's sampling distribution, which is good to know too. Mu of X bar, where it has both. Okay. H says X bar. Hypotheses. You can't really have a hypothesis test without a hypothesis test. So you still have two hypotheses, just like with proportions. The null hypothesis, just like proportions, just instead of P equals, it's going to be mu equals something. Whatever you think it is, the hypothesized mean. And so for the alternative, it'll be mu not equal to, less than, or greater than the exact same number. Okay, so I told you this with proportions. You can also write this out in words, but if you use words, make sure that you're precise, that they make sense, because that messed some of you up on the test. Like if it was greater than, make sure that really means greater than and not increasing. Those are two different things. Like greater than and increasing are two different things, and that kind of messes up when you start describing the characters. So we'll talk about that. A is the assumptions or conditions. We already know what those are. In the name, so it's a one sample t-test. T. Oh, okay. T is the test statistic. Test statistic is always how far away from the mean it is. Okay, so when we did proportions, it was the z-score. When we do means, we're using a slightly different formula, so it's a t statistic. To call it t-score. But it tells you the same thing. It's how far away from the middle the mean is. Okay. Then you find the p-value. Both of these we're going to get from the calculator. As you said, you're okay with that. Obtain the p-value. It's creative. Yeah, as long as you know what it means, I guess. Okay, last two parts are the most important. Says make a decision. So once you get your p-value, this works exactly the same way. There's two decisions you can make, two possible decisions. What are they?
Reject the null hypothesis or fail to reject it?
Yep. Reject the null hypothesis or fail to reject. Okay, good question. Can I talk about it in a second when we get to the problem? Okay, but that is a good point, because this does not mean the same thing as accept the null hypothesis. When do you reject the null hypothesis? Yes. Lower than what? Yeah, your significance level if you have one. If you don't have one, then just it has to be low. Significance level. So if it like says significance level is 0.05, it has to be lower than that. and then hopefully starting to get the hang of this. Once you reject or fail to reject the null hypothesis, then you make a statement in context. So that's where you say either there is evidence of whatever you're trying to prove, or you fail to reject and there is no evidence. This is all review of your green side. Just a difference. Alpha. Yeah, the significance level. That's the simplest. And we'll talk about when we get to a problem, but usually you say there's evidence of the alternative, and there's no evidence of alternative, because that's what you're usually trying to prove. Okay. Anything on that that's just mind-blowing, you've never seen before, you have no idea what I'm talking about? No? You're good? Ready for homework? Yeah. Okay. Super. Let's do a quick review of our errors and then we'll get to our examples. Okay, anyone remember what a type 1 error is?
It's true.
What is true? Yes. So the null is true, but we make an error, so what do? We reject it. Type 2 would be the opposite.
So it's false.
Right. The null hypothesis is false, but we fail to reject it. Okay, and then probably the one most everyone had trouble with, describing the power.
The ability.
Good start.
The ability of the test.
Yeah, then that's where we have problems. I'm like, but really test determine something. Something important. What? Okay. The residual. That, where'd you pull that up? I didn't talk about that in like October. Okay, so it's the ability to test to determine or predict when the null hypothesis is false. Or, I'm going to try to write it a better way than I did last time. That maybe will help you. So it's the ability to test to determine that the alternative is true, which is the same thing as the null is false. How do you want to write that? It just depends on the situation. If we're given that it is. Okay, so the power is not an error, it's making the right conclusion. Okay, it's really rejecting, another way, right? It's rejecting the null hypothesis when it is false. Because if it's false, that's exactly what we should do, is reject it. Does that kind of make sense? So power is a good thing. I'll show you an example in a second. Okay, 2 examples. Can we cover that in 20 minutes? So we're going to test a claim, number 3, so skip a few pages. We're going to test a claim that it takes students, an average, of no more than 2 minutes to complete a simple maze. Do you think that's true? So this will be fun then. Okay, let's go ahead and write out as much as we know so far. So, what is the parameter that we're testing about?
The time it takes to.
Okay, hold on, before you get too far. What is this?
Average.
Mean. So it's either average, so it's the mean what?
Meantime, it takes to the pace.
Yes, the mean time to complete. You want to look at the screen?
Yeah.
For everybody else's sanity. So what is the null hypothesis?
It takes 2 minutes, yeah.
It takes 2 minutes. So if you wrote it out in words, it would be the average time it takes to complete a maze is 2 minutes. Personally, why would you do that? It's a lot. So what's the alternative?
That it does it's not
Is it less than, greater than, or not equal to?
less than.
Yeah,
Less
no
than
more
or
than. Okay? So again, if you wrote out in words, it would be the mean time to complete the maze is below 2 minutes or less than 2 minutes. Not decreasing by 2, it's just less than. Okay, now we need to get to that. So you guys get to be the sample, as always. Best sample. So you are going to complete a maze. Are you good at mazes? It's a simple maze. I'm still not good at it.
I thought that was a good one.
Okay, what did you say?
He said,
He's
he's
amazing.
amazing.
Yeah.
That was Logan. That was Logan.
Somebody. Okay, so I'm going to give you a maze. You need to keep it turned upside down until I tell you. And I need a timer. First, I'm going to pause.
And then the graph.
Let's just tell them the rat.
Okay, so the last condition is the sample size one. So there's 2 ways to check it. Either n is bigger than 25 or 30. No, we're close though. It's really close. So what's the other way we can check? Yeah, we're looking for a approximately normal unimodal symmetric. So I'll go and tell you right now, it's not very good. I was hoping yours would be a lot better. That's why I was doing this class. But that didn't work out.
How do you do this?
Okay, so we'll just go through the steps just so you can see it in case you weren't here. So we want to look at the histogram. You go to second y equals, yeah, I changed it. Hold on. Make sure the plot's on and it's a histogram. So is that what yours looks like?
Yeah.
That's fine. What I tried to do, but I don't want to take the time to do right now, if it's really skewed like that, is it unimodal, first of all?
Yes.
It is unimodal, so that's good. It's skewed which way? Right. So what does that mean? What happened when they were being timed? Do you know?
Hello.
Well, yeah, it means most of them were right here, kind of around the same number, but then there were a few that finished a lot slower than everybody else. So I tried to play with the numbers earlier, and we tried to make it less skewed, but it never really got any better. And you can do that. That's a little bit better. It's still pretty skewed. So I changed it to 0.5 and 0.35. All the calculator does is it puts the lowest number and the highest number and then like divides by some number. I don't know. And so I try to make it a little more reasonable, but it didn't really change the graph a lot.
Do we have to sketch that graph?
Yes.
You do have to.
Yeah, I mean very quickly.
We catch the graph on the thing.
Like do that. I mean just awesome. Here we go. That's my sketch.
What's your y next?
What? My y what? Whatever it ends up being 10. Super. Okay, I don't know if you remember this, but I think I said this on Friday. The closer this is to 25 or 30, the less perfect the graph has to be. If we use samples of size 3, 4, 5, then your graph better be extremely unimodal and symmetric. But the bigger the sample is, the less unimodal and symmetric it has to be. So this one's really not too bad. Okay, it is unimodal. We'll see. somewhat symmetric, but not
Very not.
but not too symmetric. Oh well.
You have to address that it's that you're gonna keep going on because
You could, if you really want to be specific, you could say it's not symmetric, but 20 is pretty large, so we're okay.
you're gonna put down the 80.
Yeah, so 25 is how high it needs to be, so we're pretty close already. Okay. Everybody pay attention, we're going to go fast from here. If you still have questions about the graph, ask later. We can do the rest of this. Okay, so that's the assumptions in. What's the name of this test?
Yes.
Okay, well, no. It's a one sample test. So we need two things from the calculator. The t-test statistic and the p-value. Okay, so go to stat, count, nope, test. It's the second thing, the t-test. There's two ways to enter information. When you have a list, like we just did, go to data. So use, and you have a list, which you did. I'll show you when to use the stats. So even if yours automatically comes up with stats, go to data. The first thing it asks for is the mu. That's our null hypothesis, so we would put in 2. Help each other. If there's something you don't understand, see if a neighbor can show you what to do. What's our list? L1. Frequency is 1, and change this to less than.
The frequency should be what?
1.
T-test.
Okay, so I got that the t is negative 3.61, I guess. Anyone else get that?
Yeah.
What did you get for the p-value?
9.3.
9.35.
So the negative 4 says 0.
Right. So
9.35 to the negative fourth, so that would be 0.009 if you want to write a decimal, or you could just put 0. Basically 0. Don't, here's what you should not do. If you put 9.35, that is wrong. P-value is a probability. It should never be above 1. So pay attention. Watch for that E.
If we wrote times 10 negative.
Well, yeah, that'd be fine. For all practical purposes. Okay, so 2 parts conclusion. Part 1.
Yeah, reject the hypothesis.
Reject the null hypothesis because this is low. I didn't give you a significance level, but it really doesn't matter. 0 is pretty much lower than everything. That's not true. What's our conclusion in context? Yeah, you can write p-values low. But then there's evidence. Look at the question. What are we testing?
To suggest that it takes the average student or
Yeah. So if there's evidence to suggest that it takes students no more than 2 minutes to complete a Or there's evidence to suggest that it takes students a mean time or an average. Almost didn't put that in there. Make sure you say mean or average. Okay, what's the p-value mean? What is a p-value? It's a probability. So you could say the probability is, or there is a 0% chance of what? Right. There's a 0% chance of, say, finding a mean time less than 2 minutes, below 2 minutes. But don't stop there. If you stop there, it's wrong. That's not what the p-value is. That is the probability given that the null is actually true. So there's a 0% chance of finding a mean time that's less than 2 minutes if we're given that, if, say, it takes an average of 2 minutes. Okay, and we're talking about the population when we took the p-value. So we're saying if all students, you can just say this school, took the maze and it took them exactly 2 minutes or more, then there's a 0% chance that in one little sample that we find the opposite results. So is that likely to happen? No, so we're saying it's probably not true. Okay, quickly, this is easy because you already have your calculator. The corresponding confidence interval. So you just go to, this is what we did Friday, go to the t interval in your calculator, it's a one sample t interval. It saves everything, but there's one thing we have to change. The confidence levels. Well, it didn't really say, yeah, we could use 95 because we didn't really have a significance level in this one. It doesn't ask you, but does that support our results, our conclusion? Our conclusion that it takes no more than 2 minutes.
See everything's below.
The interval is saying that the average amount of time is somewhere between 1.22 and 1.79. Isn't that below 2 minutes? Yes. Okay. Any questions? Does it seem like something you've already done? You notice the only thing that's different is a different kind of interval, different kind of test, this one big conclusion. It's same thing. Okay, let's see how fast we can do this last one. I want us to finish today so you can wear it to work tomorrow. This one's easier. Well, there is one reason I want us to do this, but I'll go fast. Read it. I'll read it to you. What's the sample size? 91. Okay, so our conditions for inference. First one, random sample. Does it say that?
Yeah.
Yeah, so don't put representative and unbiased because that's not even needed. It tells us it's random, that's even better. Okay, 91 is less than 10% of all cars. Okay, the third condition where we had to make a histogram. First of all, we don't even have enough data to make a histogram. But we don't need to anyway because 91 is our sample size. Okay, so 91 is, you can just say it's large enough to assume that it's nearly normal or approximately normal.
It's like the sample size is 25 and 30. Should you go ahead and check it just in case?
Sure. But even if it's bigger than 25 or 30, even if it's horribly skewed, it doesn't matter. Okay, what's our parameter? Anyone read it?
Freedom.
I mean, what are we measuring in words?
Freedom, weight and column.
Okay, so the mean weight. Am I going too fast or is this fine?
No.
Okay, I don't want it to hold anybody. Don't go too slow. I'm trying. So what's the null hypothesis?
Q is equal to 3,000.
Yes, so it's 3,000. And the alternative?
Yeah. Oh, there's 94, right?
Not. Okay, so here's one of the main reasons I wanted us to do this problem. To perform the mechanics of one sample t-test. But this time, do you have a list? No. So go to stats in the calculator. When you don't have a list, when you just already know when it gives you the mean and the standard deviation, you go to stats. You go to test, t-test, go to stats, and it'll ask for first the null hypothesis. Yes.
3,000.
3,000. X bar is the mean. 2919. The standard deviation, t-test. Yes, t-test. And n is 91. Not equal to. So it's really a lot easier if you don't have a list. What's our conclusion? Two parts. Part one.
We failed or something?
You fail to reject the null hypothesis, so you say there is no evidence. We failed to reject. We didn't. When you fail to reject, it's saying you didn't really do what you were hoping to figure out, what you were hoping to prove. So there's last question. Tells us what you can interpret. There's no evidence at the mean weight. No digit. So there's no, it's not changing. Yeah, we don't care if it's changed. It's just not 3,000. There's no evidence in the mean weight is not 3,000. Okay, so someone asked, and I know several people wonder this, why can't you just say accept the null instead of saying fail to reject? If you say accept it, you're saying that this is true, that the mean weight is 3,000, but you really can't say that. All you can say is we need more evidence. It's almost like it's inconclusive. We're saying there's not enough evidence to suggest it's greater than or equal to greater than or less than 3,000, but that's really all we know. Okay? If you accept it, you're just saying it's true, and we never know for the null hypothesis. It's like we need more evidence. It's like you need to gather more samples. So what? Can anyone interpret the power for me?
The test, the mean weight of cars is
Okay. You can say it's the ability of the test to correctly determine that the mean weight is not 3,000. If you word it like this, it's important that you put correctly. Otherwise, you could say something like this: the ability of the test to determine that the mean weight is 3,000 if this is correct, or if it really is. We're saying that the test did what it's supposed to. When the mean weight wasn't 3,000, it rejected the null hypothesis. So it's probably not a bad idea to add it. So it's the ability of the test to correctly determine that the mean weight is not 3,000 if it really isn't 3,000.
That's right. We lost that.
Well, you're saying if you have a group of cars and their average weight really isn't 3,000, but the test said that it was 3,000 approximately, then the test was wrong. But if you have a group of cars and the mean really isn't 3,000 and the test said it wasn't 3,000, that's the power. It did what it was supposed to do. The mean wasn't 3,000 and the test said it wasn't 3,000.
So, is there a number?
Yes, it's a very, very complicated formula that you don't have to know. It's a probability. Yeah. a fun tree diagram probably. Okay, do you want me to write these out, or do you know? Can we just say words? Say. Okay, what's a type 1 error?
No one's true, but we decided.
Okay, context. Okay, so type 1, the mean is 3,000. We say it's not 3,000. Type 2, it's not 3,000. We say it is. That's pretty deep.
Pretty neat.
That's pretty deep.
Pretty deep, man.
It is.